Welcome back. Video for 3.5 part 2. This one at least you're going to get to do some GSP discovery stuff on your own, so you don't have to listen to me talk the whole time. So start up here. It says because the sum of the measures of the interior angles of a polygon depends on the number of sides n, right? You notice that every polygon as one side was increased, the total number of interior degrees increased by 180 degrees. So do you think the same is going to happen for the sum of the exterior angles? So let's see what relationship it has. So what are you going to do? Well, you need to open your GSP. You can pause, open your GSP, and just do this activity. You're going to follow through these steps here, and you should see what happens. So go ahead and pause, do the GSP, and then you'll discover what happens. So hopefully you got a diagram that looks something like this. And you can then discover, well, I thought maybe you'd be confused about what to do with this angle marker right here. So number 5 says create an angle marker on each angle. So how do you do that? Well, this is the marker right here, and you go down and you choose from here to here, and that's super nice. And you do that for every exterior angle. Notice I'm going from the side of the polygon to that ray, from the side of the polygon to that ray, from the side of the polygon to that ray. So these are my exterior angles. Then I go up here to measure. Sorry, I have to select them. So I'm going to go up here and click out, right? I exit or escape, and I highlight the angles. I should be able to do that. There we go. And I push my shift key, and I'm going to highlight all of the angles around, because this is just going to be a super fast way to find the measures of the angles. And I'm going to go up to measure and angles, and there are all 5 of those angle measures. It's so nice. So it calculated it for you. Okay, and if you didn't have vertices labeled, it labeled it for you. So now you can see all these angles right here. So now we need to calculate the sum, right? So let's calculate the sum. So what do? We go up to number, and right at number there's this word calculate. So go up at the top. You can't see mine, but it says calculate under number. And look what I can do with this calculator. I can just drag this in or push it, and then I can push plus, and then I can put the next one plus, the next one plus, the next one. Because remember, we're trying to find the sum of the exterior angles. And so now I just push OK. So what is my sum? Well, my sum, it looks like, is 360 degrees. So let's check that out. So that's interesting. All 5 of these exterior angles have a sum of 360 degrees. Well, let's see if that's going to change. So we can choose a vertex, right? And as long as I keep my polygon, my pentagon here convex, look at these numbers change over here, but does this total sum change? No. So as I change this, does my total sum of the exterior angles change? No. So is that only true for a 5-sided figure? What about the people who made the triangles? What did their exterior angles add up to? What about the quadrilaterals? What did their exterior angles add up to? So no matter what, see if this one gets bigger, this one's compensating by getting smaller. So all of these are going to add up to 360 degrees. Now think about why. I want you to think about it, and we can talk about it next class if you're not sure why. But until then, just think about why would that be true. Okay, so theorem 3.14 says the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So no matter what, no matter how many sides you have, a decagon, dodecagon, a 32gon, the exterior angles will always add up to 360 degrees. Now we're going to apply that information to do problems to practice. But one of the vocabulary words that they kind of sneak in there on you and don't make a big deal of is about a regular polygon. So what is a regular polygon? You will see this word so often. You must remember, and you must kind of circle that as you see it in problems, because it's a big deal. If a polygon is equilateral, it can be equilateral or equiangular, but if it's both of these, both equilateral and equiangular, then we call it a regular polygon. So equilateral and equiangular, then it is a regular polygon. So how can we solve these problems knowing that? Okay, number one. What is the measure of one interior angle of a regular hexagon? Okay, so we have a six-sided figure. If we want to find the interior sum, so the sum of the interior angles equals 180 times the number of sides minus 2, right? So that's 180 times 4, which we get what? So 720 degrees. But that's not the measure of one of the interior angles. If it's a regular hexagon and it's regular, that means every single angle is the same measure. And if every single angle is the same measure, then I'm just going to take the total sum and divide it by what? By the number of angles, the number of vertices, the number of sides. How many angles in a hexagon? There's 6. So I'm going to take this number and divide by 6. I'm going to take this number and divide by 6. So what do I get for every single angle of a regular hexagon? That's going to be 120 degrees. Okay, the next one. What is the measure of one of the interior angles of a regular n-gon? Okay, so regular. Any interior angle. So basically, it's this formula right here, right? What do we do to find one specific angle? We take the total sum of the interior angles, and we divide it by the number of angles, right? Or the number of vertices, or the number of sides. Maybe sides is a better word here since we're using sides for n. So it's 180 times n minus 2, that's how we get the total sum, and we divide it by n. So if we're trying to answer number 3, it says, what is the measure of one exterior angle of a regular decagon? Okay, how many sides does a decagon have? It has 10 sides. So what are we going to do? We're just going to plug it into this formula. That's 180 times 10 minus 2. That's the total sum, but then we have to divide by how many sides we have to get the total per angle, because every single angle measures the same. So what do we get? Oh, sorry. Ooh, what did I do here? My fault, my fault. It's exterior angle. I'm so sorry. So this is wrong. That's interior. So exterior angle. What do we know about the exterior total? So exterior total is 360 degrees every single time. This is the exterior sum. And we divide that by what? Well, we divide that by the number of sides to get what it is per one exterior angle. So it's 360 divided by n. Well, a decagon is 10 sides, so we get 36 degrees. So every angle is 36 degrees. For the next one, number 4, what is the measure of one exterior angle of a regular n-gon? Well, this one's a little easier, right? This is it right here. We take the total sum of the exterior angles and we divide it by the number of sides. Well, the total sum, no matter what, every single time is 360 degrees. How many sides do we have? We don't know. It's unknown. So we can just plug that number in to figure it out. Okay, you have a few more practice problems. What I'd like for you to do is pause, go through them on your own, talk to people in your group and see if you can get the correct answer. And then you can watch the video for an explanation, or you can look at the answer key up on the front board. Okay, so go ahead and pause and try. Okay, you should have gotten B equal to 90 degrees right here. So B equals 90 degrees. So you want to check. If you want to check, pause. But basically I added up all of the information up here. So every single one of these I added up because those represent the angle measures. I added them up, set them equal to 540 degrees because a pentagon has a total of 540 degrees. When I added them up, I got 22x minus 54 equals 540. I added the 54 to both sides, divided by 22, and I got x equal to 57. But of course, that's not the answer. The answer is find b. So I took that x, and I plugged it in here for x, and I distribute my negative, so I get negative 18 plus, because double negative gives me plus 108, so my b equals 90 degrees. Find the measure of an interior angle and an exterior angle of a regular polygon with 30 sides. So interior, that's just this formula. 180 times the number of sides minus 2 divided by the number of sides. So when I plug it in, I get 168 degrees. Right? That's 180 times n minus 2 divided by n. The formula for exterior, so I did exterior in red. Right, and that's 360 divided by the number of sides, so 360 divided by 30, I get 12 degrees for the exterior angle. The next one's a bit trickier, so I'm going to do it with you. It says find the number of sides of a regular polygon. So again, regular, that has an interior angle of 171 degrees. So this formula equals 171 degrees. Well, if you make it over 1, you now have a proportion where you can cross multiply. Right, so we're going to cross multiply here. So 1 times this just becomes 180 times n minus 2, and 171 times n just becomes 171 n. I distribute, so I'm going to write it up here. I get 180 n minus 360 equals 171 n. I subtract 180 from both sides. So negative 360 will give me negative 9n. Therefore, we divide each side by negative 9, so we get, oops, not degrees, but there are 40 sides. So the question is, how many sides do we have? We have 40 sides. So we went backwards in that formula. Just like number 8, it says, find the number of sides of a regular polygon that has an exterior angle of 7.5 degrees. So exterior is easier. It's 360 degrees divided by the number of sides. That has to equal 7.5. Again, make it a proportion, cross multiply. So we get 360 equals 7.5 n. Divide each side by 7.5. So therefore, n equals 48. So what does that mean? That means this particular polygon has 48 sides. So notice you're not going to be able to guess and check these. You're going to have to memorize these formulas and know how to apply them. So you have to do your homework this weekend and practice it. And come see me on Monday during lunch if you're having trouble. So you must do that so you can practice to see if you understand what's going on. All right, and finally, this last one is a little bit tricky, so I wanted to do it with you. So I'm going to translate it exactly. It says the measure of one interior angle. So the measure of one interior angle. So that's 180 times n minus 2 divided by n. That's the total sum divided by the number of sides. That is, so remember the word is means equals. 3 times, so that's 3 times the measure of one exterior angle. So the formula for exterior angle is 360 divided by n. Now you just have to solve. So if you have 180 times n minus 2 divided by n, and you have 3 times 360 divided by n, well, if these are the same denominator, you can pretty much just set the numerators equal to each other. So go ahead and do that. We have 180n minus 360 equals 3 times 360, which is 1080. 180n equals 1440. Therefore, n equals 8. So there are 8 sides to this particular polygon. Tricky, I know, but the nice part is you don't have to cross multiply with that n. Then you would have a quadratic, even though it would cancel. So if your denominators are the same, just set these numerators equal to each other and go from there. Right? If you have 5/3 equals x over 3, well, if they have the same denominator, that means x has to equal 5. These have to equal each other. So that's what we just did here. These have to equal each other. All right? Okay, good luck. Practice the problems from the textbook, and I'll see you on Monday.